Hey folks, welcome to my channel number 10. So there we have the problem on the screen. Integrate the following with respect to x. We have e to the power x times tan x plus log secant x, right? So what we've been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let us write down what our y is. So that's my y, integral of e to the power x times tan x plus log secant x dx, right? Now how do we go about solving this particular problem, right? Now when you observe this very closely, you see that I can connect my tan x with a log secant x, right? What is the connect there? My d by dx of log secant x is nothing but a tan x, right? And you also should remember that d by dx of e to the power x is always e to the power x, right? So let's assume I make a substitution t equals e to the power x into log of secant x, right? And you'll slowly understand why are we doing this particular substitution. So let me assume t equals e to the power x times log of secant x, right? Now I'll have to figure out what is my dt, right? So I differentiate on either side. My dt equals, I have a product of two functions, right? I have my e to the power x and I have log of secant x, right? Now what happens when I differentiate the RHS? My d by dx of e to the power x is e to the power x. Then I have a log of secant x. I'll have my dx here. And then I come to the v part, my d by dx of log of secant x is nothing but 1 by secant x into secant x tan x, right? So I will end up with e to the power x times tan x dx, right? This is what we have when I make the substitution t equals e to the power x log of secant x, my dt equals, and this is where I know that my e to the power x is common and so is dx. Therefore, I can rewrite this as e to the power x times log of secant x plus tan x times dx, right? Now you see, am I in a position to make my y a lot more simpler than what it looks like by making this particular substitution? The answer is yes. Let's do that substitution. So when I do t equals e to the power x log of secant x, my dt becomes equal to e to the power x log of secant x plus tan x times dx, right? So my y becomes integral of dt, and the answer for this is nothing but t plus my arbitrary constant c. And what is your t is the substitution that we made, which is nothing but e to the power x log of secant x plus c, right? So when you take a look at this particular function, and we're going to look at similar problems in the upcoming videos, you will notice that this is a function of the type, right? Let me write it out here for you folks. This is a function of the type e to the power x times f of x plus f dash of x, right? So in this particular case, you take a look at it, your f of x is log of secant x and your f dash of x is tan x, right? So the expression dot what you've been given is e to the power x times f of x plus f dash of x, right? And whenever you've been given a function of this type, the answer for that is e to the power x times f of x plus c, right? Now, I don't want you to memorize this as a formula, but I want you to keep this in mind and try and make the appropriate substitution when you get a problem of this type, right? So there we are. So let me highlight my final answer in pink. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.